So, here you are, in quarantine, looking for a nice cup of coffee. Now, as you leave the house close to dusk to avoid the busy streets, you start walking along and notice that none of your favorite spots are open. You're searching high and low, but that one's closed, and that one's closed. And even a coffee party down the street, which no one ever goes to, has its doors shut. So what are you to do? Well, you might stroll around looking for an eatery. And it turns out that there is one there. Pie Time serves both lattes and some good apple crumble. And so you're waiting at the counter, and because it's so late, they let you sit down. But the problem is, you take out your computer and you see this. Now, it's been a while since you've had calc, and you sort of recognize the integral symbol, but you can't for the life of you figure out what to do. Well, today's your lucky day, because that's what I'm here to help you with. Okay, so before we get started, there are a couple things that I'm going to expect you to sort of have a familiarity with. It'll make this go a lot faster. So the first thing is integration. Okay, the process of integration, what a definite integral is, and sort of how to calculate basic ones. The idea of substitution and the idea of limits. Okay, number two, a little bit of trig. The only thing you need is the Pythagorean identity, and maybe to understand that there are a couple more out there, say the power reducing formula, that make your life a little bit easier. Three, imagination. Well, we can brute force our way through a lot of the calculation here. It turns out that there are a couple simple rules that will help us make this a walk in the park, but perhaps not to a coffee shop. Okay, so the three things I'm going to talk about that are the bedrock of the solution here. The first being the most important and the other two being kind of important are the following. Symmetry. Particularly the symmetry present in even and odd functions. So we'll do a little quick review of that concept, and we'll discuss why it's so important to making integrals really easy to solve. 2. Recognizing common functions. So being able to see when there's something that makes geometric sense or something that makes sense based on your past experience, that let you solve more complex integrals really quickly. Identifying these patterns will really help you out. And then 3, the last thing, trig substitution and or trig identities. Now, I did say I will presuppose that you know some of these. I'm just going to go over that really quickly. Trig substitution is maybe a new idea, and we won't go into depth with it here, but note it is very commonly used and makes some integrals possible or much easier. Okay, so those are the three things you need. This should be largely solvable at a Calc 2 level, but let's break it down. Okay, so at this point we've made a determination of the oddness and evenness of various parts of this function. So at this point what we're going to do is we're going to break this apart after distributing so that we can look at it more clearly. Okay, so I'm going to use purple for this whole process. Very nice color. props to Murphy. Okay, so what we have here is an integral that looks like negative 2 to 2 of x to the third cosine, if we're distributing to there and to there, cosine x over 2 root 4 minus x squared plus root 4 minus x squared over 2. This times that. Okay. And if I split this up, really what I should be doing here is take this as an integral and this as an integral. And let's first evaluate this one on the left. So this is where even and odd comes in. I have a symmetric interval. I have an odd function multiplied by an even function, which is odd. So this whole thing here is odd, integrated from negative 2 to 2 with a definite integral. And that means it's all 0. The left side and the right, the left side of the axis and the right side of the axis, they'll cancel each other out. One side will be negative, the other side will be positive, and or 0 on both. And we'll get a 0 value, which means that this entire thing is equal to this thing only. So we've automatically cut out the problem to be something very simple, relatively. So this integral up here is equal to just this. Okay, well, let's simplify this slightly and try to figure it out. There are two ways we can do it. I'll show both of them, and it should be a piece of cake, or, well, pie. Okay, so what we get is 2, 1/2 rather, of the integral from negative 2 to 2 of root 4 minus x squared dx. Now remember, the Riemann integral tells us the area under the curve here, and what we can do is look at this function and have a nice intuition. This is a function where the radius is 2, and we're taking, in effect, the area of this slice. Now the area of this, just by intuition, well, what's the area of a circle of radius 2? It's pi times 2 squared, which is 4 pi. But we don't want 4 pi, we want half of that, half of the circle. Or if you were to just consider the symmetric interval, we'd want the positive part of the interval, we'd only want 1/4 of that, meaning just pi. But we'll worry about this here. So actually, we want this here isn't 4 pi, it's only this part above the axis. This is 2 pi. And we take 1/2 times 2 pi, and we get pi. So we went from eliminating this almost immediately, making it 0, to realizing that this is just describing the area of half of a circle of radius 2. So we didn't have to do any integral calculation at all. We just had to use a geometric observation. This problem really is very pretty because it shows the power of symmetry and observation to make complex looking problems, or even complicated problems, much easier. Hope you enjoyed. Now you can sit down, maintain your 6-foot radius, and enjoy your pie.